Hello everyone. Today let's solve the problem number 918, maximum sum circular subarray. Right. So what the question states here, we are given a circular integer array nums. See here, circular integer array nums. We have to return the maximum sum of the non-empty subarray. Right. Maximum sum of non-empty subarray. Right. So this is very important. This word, non-empty subarray. A circular subarray may wrap from the end to the start, but each element can be used at most once, right? So that is the reason we have to find the best subarray sum, nothing but non-wrapping or the wrapping using a greedy, right? So greedy approach basically. So we'll be going with a cadence algorithm for this whenever we have to find something greedily. So usually let's check with the cadence algorithm first, right? So we will be going with a this one, greedy or the cadence algorithm to solve this particular problem. Just remember this one, right? Greedy or the cadence algorithm. Right, just remember this one. Just let me delete this one entirely. Now let's, I hope the question part is completely clear, man. All we have to do is, we have been given a circular integer array nums. We have to return the maximum sum of the non-empty subarray, right? So this is what we need to do. So certain criteria they have given, I have already said this one. Let's come to the example one. First example here. See here we have minus 1, minus 2, 3 and minus 2. So subarray 3 has maximum sum 3. See here this one they are speaking of, subarray 3 has maximum this one sum 3, quite obviously, right? So for the second one we have 5, minus 3 and 5, right? So subarray 5 and 5 we can consider as this is circular this one array, right? So subarray 5 comma 5 has maximum sum which is equivalent to the 10. This is fine. Now we are left with a last example. We have minus 3, minus 2, this one minus 3. So among this, the least one, as we are going with a negative value, the least value we need to consider, right? So max we have to this one return. So the least value here is minus 2. So I'll just go with the minus 2 here, right? Quite obviously subarray minus 2 has the maximum sum of minus 2, right? So this is fine. Now I hope this part is completely clear, man. So let's quickly discuss the approach followed by the complexities and then let's write the code, right? So let's quickly discuss the approach. So let's consider the same thing here for the approach, right? So first thing I want to tell you here is we will be making use of this one, cadence or the greedy algorithm, as I've said, right? So we will be initializing max ending that is equivalent to the max so far, right? And also max ending this one, max ending equals max so far equals total, that we will be initializing that one to the 1 initially, right? Let's see the this one, process 1, process 2 as well as the process 3, right? So here let's we have to go with the initialization, nothing but we have this number 1, minus 2, 3 and minus 2. So so this one what we will do initially, max ending. So this one we will be going with min so far, max ending, minimum so far. I'll just go with the mf here, and also let me go with the total that is equivalent to 1, right? So this is first for the first element or the first number within the array. Let's go with the process 2 here. Process 2 or let me consider process minus 2. So this one we are processing minus 2, right? Element minus 2. So max ending equals max of minus 2 comma 1 plus of minus 2, right? So max of minus 2, 1 plus of minus 2. First we'll consider this element and the previous element plus this one, the current element, nothing but 1 plus of minus 2, right? So this one will be max equals minus 2 comma 1 plus minus 2. So this one will be minus 1. So max so far is 1, max so far is 1. So here max so far, nothing but the max so far I have considered f. This one will be max so far will be mine sorry 1, right? So we got 1, and minimum ending will be min of minus 2 comma 1 comma same thing 1 plus minus 2, right? So this one will be minimum we are considering. So instead of the max we are considering the minimum, so minimum will be minus 2, right? So minimum will be minus 2. So minimum ending, so this one will be, we are not considering the maximum, we are considering minimum. So minimum will be quite obviously minus 2. This is fine. This is for the process -2. Now the same thing we will do for process 3 as well as the process 4. For the process 3, so max ending will be 3 comma -2 plus 3. So current number, previous number, current number comma previous number plus current number, right? So this one will be for the max ending. So max of 3 comma -1 plus 3. Max will be, max so far will be 3 for this one, and minimum ending same thing. What do we call 3 comma, so instead of this one, a previous minimum value we got here is -2, so we'll be going with the previous minimum value. So here this will be 3 comma, what do we call, -2 plus 3, right? So minimum of 3 comma 1 is quite obviously 1, right? So minimum so far will be considering this one, what do we call, -2. So -2 we will be considering again. So -2 was the is the least that we got, that we have got here. So one among 1 and -2, which one is the least? -2, right? So we will update minimum ending with -2 itself now as well. Right? So we'll not update this one with a 1 basically. So this one remains. Sorry, I don't have place at all, man. Let me do one thing. So I'll just go with the minimum. I'll just write here -2. So we are left with only one process here, process 4. This one -2, we have went with 3. Again, we'll be going with a process -2, right? So this time we have different values, right? So now max ending will be same thing, max of -2 comma 3 plus of -2, right? So same thing will be going with. So maximum so far we will find here this one, maximum so far will be 3, and we will be going with a minimum and a min ending that is equivalent to the min of -2 comma 1 plus of -2, so which is equivalent to the -2. Minimum ending is equivalent to the -2. This is fine. So this one minimum ending will be -2. So minimum so far we have got here is -2, and total is 0, right? So minimum so far is that we got here is, so this one minimum so far that we got is -2 itself, right? So we don't we haven't updated after -2. -2 was the least that we got, right? So this is fine. Total is nothing but 0. Total is nothing but here in this case 0, right? So total is nothing, we have to go with the total minus min so far, right? So total minus minimum so far is, so this one will be, total is 0, and we will be going with minus of -2. Total minus minimum so far is the formula that we'll be going with to for the answer. Basically this one will be +2, right? So we will be going with max uh, of this one. What do we call, maximum we have to go with, right? So maximum is 3 that we have got here. Maximum of 3 and 2 will be quite obviously 3, right? So maximum of 3 and 2 we got here is 3. Maximum of 3 and 2 is quite obviously 3, right? So this one we will return in the form of output. So here we got output 3. The output that we got here is 3, which is equivalent to the output that they have given for the example 1 within the question, right? Example 1 within the question. So the output that we got here is 3 again, which is equivalent to the out this one output that they have given for the example 1 within the question. So our approach works absolutely correct here in this case. As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity and the space complexity here? The time complexity would be big O of n. Again, the time complexity would be big O of n. Why it is big O of n? Because we are going, or we will be going with a single pass over the array with a constant work per element, right? So quite obvious the time complexity would be big O of n. Greedy, so we should be knowing big O of n. So what will be the space complexity? Again, big O of 1, right? So why it is big O of 1? Because we will go with only a handful of primitive variables, right? So will not make use of any extra arrays or the collections as well. So overall space complexity would lead to big of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of 1 respectively. Now as we are completely familiar with the approach as well as the complexities, we are good to write the code. Let's start writing the code. right? So first, let's do one thing. Let me go with the length of the input array first, right? So I'll just go with int n equals length of the nums, right? So this is fine. Next, let's initialize the cadence variables with the first element that handles the single element arrays. So here in this case, I'll just go with max ending. So this one will be nums of 0 man. So this is fine. Again, we have to go with the max so far, max ending, minimum ending also we need, minimum so far also we need, again total. These are the five things we need, right? So along with the this one, nums of the length, will be making use of the length of the nums mostly everywhere. So I have just assigned this one to the variable, this one n. I don't have to write nums dot length everywhere, right? So here we need max so far. So this one will be, let me do one thing. Everything I have to initialize this one to the num0, right? So let me copy paste this one and make the necessary changes. Max so far, min ending, min so far, as well as the total. So this one will be, so let me write here max so far. This is fine. So the third one here would be min ending, right? So I'll just go with the min ending. This is also fine. The fourth one will be min so far. So this one will be min so far. This is also fine. The final one would be total, right? So total will be equivalent to the nums of 0. This is also fine, man. Fine. Now let's do one thing. Let's iterate from the second element to the end, right? So I can just write the simple for loop here. Int I equals 1, I less than n. So let me go with I plus plus. So within the for loop, let me do one thing. Let me assign x to iterated value of the nums. So this is fine. So we are just going with the current element here. Now what we'll be doing, we'll be going with a greedy step for the maximum subarray that is ending at I. We know this. So either we can start new at x, or we can extend previous maximum ending by adding the x. That we can do, right? So I'll just go with here max ending equals math dot max, this one x comma max ending, this one is fine, plus x. This is fine. Now I'll just go with max so far. So this one again, uh, let me copy this one and make the necessary changes, man. Let me paste it over here. This one will be instead of x. So this one will be max so far. Alright, so let me copy this one and paste it over here. And also we have to consider max ending, right? So this one, that is max ending. So let me make this one capital E, man. Here as well. So let me go with max ending. Max ending, right? So yeah, let me copy this one. Why this is showing max so far? Max ending. This is fine. Max ending. This is fine. Now, what we have done here, we are updating the best ending at I value for this one, line number 14. And in the line number 15, we are just updating the global max if it is needed, right? So now, what about the min? We have to go with the min ending as well as the min so far as well, right? So according to the approach that we discussed, maximum so far, min so far, both, right? So both we have to consider. So now let's update the worst ending at I value. So I'll just go with the min ending for this. So this one will be math.min of x, comma, this one again, max ending plus x. So let me copy the same thing and make the necessary changes for min so far. So let me copy this one. Let me paste it over here. Min so far, this one will be, instead of x, it will be min so far. And so this remains min ending itself. So I'll just remove the plus hex here. This is not required, right? So this is fine. So we know this from the approach. Finally, we have to accumulate the total sum, right? So we let's accumulate the total sum here. Nothing but in simple terms, we have to update the total sum, right? So total will be total plus n, total plus x we consider, right? Sorry, I'll just go with x. This is fine. Now let's do one thing. Yeah, if every number is negative, max of or holds the largest, nothing but the least negative element. In that case, we can go with the total minus min so far. That would be 0 basically, right? So directly we have to return max so far. So let me write the simple if condition for this rather than speaking much. So I'll just go with max so far. If it is less than 0, then I'll return here max so far. So this one will be max so far. This is fine. So sorry. Yeah, this is fine, man. Now let's do one thing. So otherwise, what we have to do, our answer is max of non-wrapping max so far. That is nothing but the standard kitten, or we can go with the wrapping case as well. That is equivalent to the total minus min so far. In our case, we went with total minus min so far, nothing but 0 minus of minus 2. I showed in the last step, right? So in we can either go with the non-wrapping max so far, nothing but the standard kitten algorithm. If you know what I'm speaking of, if you know the algorithm, you'll be knowing what I'm speaking of. Or we can go with the wrapping case, nothing but total minus min so far. Meaning here we have to remove the minimum contagious segment. That is the reason we'll be going with the total minus min so far. So we went with 0 minus of minus 2, we got 2. Again we went with max of the maximum element that we got so far, with the min, nothing but 2 we got, right? So nothing but wrapping case, total minus min so far. Finally we got the output 3, if you remember the approach, right? So I can just go to that part of video and you can see the last step I'm speaking of. So we have to return the final result in simple terms. So let me go with return math dot max. So this one will be max so far. So here this would be max so far. This is fine. And also total minus min so far. So this one will be, let me copy this one and let me paste it over here, right? So this is fine. Minimum so far. We are done with the coding part, right? So let me do one thing. Yep, we are done with the coding part. So let me format the code once and let me hit the run button. So I hope this works, man. Let's see. Compilation error. This one S has to be capital. Again, any more errors? We have, so this one, let me go with max so far. Whatever I given here. Yeah, this is fine. So, anywhere I have given, yeah, this one also. It's fine, man. Let me hit the run button now. Yeah, again, small line number 27. So this one is capital S. Now this has to work. Yeah, now we can clearly see the sample test cases are getting passed. So let me hit the submit button quickly, man. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct on this case, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.